Welcome once more. We are still on a series of quadratic equation. Today we are going to look at relationship between the roots and coefficient of quadratic equation. All right. So let's say that assuming alpha and beta. Okay, we are going straight. Are the roots of a quadratic equation. Okay, so let's assume that we have a quadratic equation whose roots are alpha and the other one is beta. Okay, we are going to look at the relationship between the roots and the coefficient of a quadratic equation. Okay, so if my roots are alpha and beta, then what will be my quadratic equation? And we have learned when we have roots, how your quadratic equation is going to be. So when I'm giving the roots, I can be able to know how my quadratic equation is going to be. All right, we know that when you are given the roots, to get your quadratic equation, you have s squared minus what? Sum of roots multiplied by s plus what? The product. And that will give you 0. So we can have alpha and beta as my root. I can have s squared minus alpha plus beta multiplied by s, alright, plus alpha beta. That is when I multiply alpha and beta equal to what? Equal to 0. Okay, so I have s squared minus alpha plus beta multiplied by s plus alpha beta equal to 0. Okay, so this is if alpha and beta are my roots, then this is how my quadratic equation is going to be. So let me put this one down, okay, as my equation 1. And then I'm going to compare to the coefficients of quadratic equation. We know that the standard form of quadratic equation is as squared plus bs plus c equal to what? 0. So this is the standard form of a quadratic equation. All right, so I'm going to compare by, so here the coefficient of the s square is what? Is 1. So I'm going to also make here the coefficient of the s square as 1. Okay, and then we see what we are going to get. So I'm going to divide here by a. So if I divide by a is going to cancel a, plus bx also over a, or b over ax, plus c also over a, all right, equal to 0. Okay, so this is what I have. Okay, and then let me see, this is the 2, my second equation. So if I compare them, all right, here the coefficient of the square is 1, and then I have b over ax, which is the same as the minus alpha plus beta, okay, multiplied by s, and then my c over a will be the same as alpha beta. All right, so if I'm comparing them, then what I can say is that here is s squared and here is s squared. That is fine. So I have minus alpha plus beta, which is the coefficient of the x, okay, to be equal to, here what is the coefficient of the s? Is b on a, okay, b on a, and then here coefficient of the x is minus alpha plus beta. All right, so if I want to get alpha plus beta, that is the sum of the roots, then what am I going to do? I'm going to divide here by -1 and here by -1. So my alpha plus beta, so if I divide here by negative, I get minus b on a. All right, so the sum of a quadratic, the root of a quadratic equation is the same as minus b plus over a, where the b is the coefficient of the x, and then the a is the coefficient of what? The s square. So the sum of the root of every quadratic equation, we can say that it is minus b on a, where b is the coefficient of the x, and then the a is the coefficient of the s square. All right, so let me also see the alpha beta. So my alpha beta is also the same as C on A. C on A. Okay, so what we can also hear is that the product of the root of every quadratic equation is what? Is C over A, where C is a constant without any variable attached, divided by the coefficient of the S square. The coefficient of the S square. So that is what we are seeing happening here. Alright, so we are going to use this, the alpha plus beta, and then the alpha beta. So we know that alpha plus beta, the sum of the root is minus b over a, and then my alpha beta is what? C over a. So this will be needed to solve some questions, okay, whereby you can begin an expression for what? For alpha and then beta, and then you make sure that you express it in terms of what? Alpha plus beta and then alpha beta, so that what? You can solve. All right, so we can be given a lot of expression in terms of alpha and then beta, so that we can use the sum and then the product to solve. Okay, so let's see an example here. So let's look at this particular guy. Given x squared plus x minus equal to, find a, the sum of the roots, and then b, the product of the roots. Okay, so let's find the sum of the roots and then the product of the roots. We are giving x squared plus s minus 12 equal to 0. So we are going to find the sum of the root of this equation and the product of the equation. Okay, but before we find the sum of the equation, we have to know our a, coefficient of the x squared 1, b, coefficient of x 1, and then the c is what? Minus 12. All right, then what is the sum of the roots? A, sum of roots of a quadratic equation is given as what? Which is my, let's say alpha plus beta is given minus b on a. And what is minus b on a? What is my b? 1. And then what is my a, which is 1. So minus b on a will give me, minus 1 on 1 will give me negative 1. Okay, so negative 1. And then let me find the product of the roots. What is the product? Alpha beta, and that is c on a. What is my c? Negative 12. And what is my a? 1. So my product is negative 12. Okay, so the sum of the roots of this quadratic equation is negative 1, and then the product of the root is what? Minus 12. So see why it is like this. We have x squared minus plus x minus 12 equal to 0. If I solve this quadratic equation, alright, we say that we multiply the coefficient of the x squared, which is 1, by the constant negative 12. The two factors of negative, which will give me the coefficient of x, that is 1. Alright, so what's two factors? We can get 4 and negative 3. Alright, you can get 4 and negative 3. So 4 times negative will give negative 12. 4 plus negative will give me positive 1. So to factorize this, in short, we have x plus 4 and then s minus 3 equal to 0. Okay, so s plus 12 and then s minus 3 equal to 0. Where x times s will give me s squared, s times minus 3 will give me minus 3x, 4 times x will give me 4x, minus 3 plus 4 will give me 1, and then 4 times negative 3 will give me what? Negative 12. So if I solve this, I'm going to have s plus 4 to be 0, and then my s will give me negative 4, or s minus 3 is 0, and then my s will give me what? 3. Okay, so either x is negative 4 or s is what? S is 3. So these are the two values of x that I have. So let me find the sum of the roots and find the product if I'm going to get the same thing here. This is what we are talking about. Okay, the sum, the root is, my root is negative 4 and 3. So the sum will become negative 4 plus 3. That is negative 1. See the same thing. That is negative b over a. Alright, and then the product of roots, what will be the product? Negative 4 times 3, and that will be negative 12, and that is the same thing as the product I have here. Alright, so it is telling you that if you want to get the sum of roots of any particular quadratic equation that you are given, then it is minus b over a, and then the product of roots of any quadratic equation will give me c on a, and we have proven that by this particular quadratic equation we have here. I believe that is understood and that is okay. All right. Okay, since now we know the sum of roots alpha plus beta is minus b over a, and the product of roots alpha beta is c over a. You can also be given other values, okay, or with the root you can be given in other forms in terms of alpha and then beta. Then you'll be asked to use the sum and then the products to evaluate what you are given. For instance, I can be given alpha square plus beta square. Okay, I can be asked to find the value of alpha square plus beta square if alpha and beta are the root of a particular quadratic equation. And what you should know is that if you have any particular quadratic equation, then what you can find is alpha plus beta and then alpha beta. All right. And let's say I have been able to calculate for alpha plus beta, that is the sum, and then alpha beta, which is the product, assuming that alpha and beta are the root. And I'm asked to find from the same quadratic equation the value of alpha square plus beta square. How am I going to find alpha square plus beta square from this particular value that I have been able to calculate from alpha plus beta and then alpha beta? Okay, one. So what we should take now, what we know is that alpha plus beta all squared. Okay, so let's say I have alpha plus beta all squared. Alpha plus beta all squared. All right. So I'm asked to find, but I'm going to use alpha plus beta all squared to be able to get my alpha plus beta and then alpha beta, so that when I'm asked a question, I'll be able to use the two calculate. So alpha plus beta all square can be written as alpha, this one, I have alpha square, which is the same as alpha square. Now, to expand this, I'm going to expand. Alright, then I multiply alpha by beta, then I multiply by 2, and that will give me 2 plus 2 alpha beta. Then I also square the beta here. Okay, so this expansion of a binomial, the square of a binomial. Alright, so what I can do is to what? Is to make alpha and beta the subject. So what am I going to have here? I'm going to have alpha plus beta all squared to be equal to, I have alpha squared plus beta squared here, then plus 2 alpha beta also here. So I'm going to make alpha squared plus beta squared the subject so that I can get my value, what I want to calculate for. So I have alpha plus beta all squared. Then I'll bring this one to be minus 2 alpha beta, and that will be equal to alpha squared plus beta squared. So our alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. So this is the same as alpha plus beta all squared minus 2 alpha beta. Why are we expressing this as this? So that because in the question, what I can get from a quadratic equation is the sum and the product. So that when I get the sum and the product, if the question asks me to find the value of alpha squared plus beta squared, I cannot find the value of alpha squared plus beta because I don't know. But what I know that from alpha plus beta all squared, I can get this. And to make alpha squared plus beta squared the subject, I now have this particular expression here. So alpha squared plus beta is the same as alpha plus beta all squared minus 2 alpha beta. So that what I have been able to calculate, the sum of the root, I will substitute here. So if I have the sum of the root as, let's say, 2, then I have 2 squared minus, if I have the product as 1, then 2 times the product. Because from the quadratic equation, what I can get is the sum and then the product. And here is my sum and here is my product. So anytime the question asks you to find alpha squared plus beta squared, then your answer should be alpha plus beta all squared minus 2 alpha beta. So that you substitute the sum and the product, you have been able to find from the quadratic equation given if alpha and beta are the root of that quadratic equation. Alright. I believe you get it where we had our answer from. So let's go to, you have understood this, let's put this one now. And then let's go to number 2. So 2, this is what we are going to look at. If I'm given to find alpha minus beta all squared, alpha minus beta all squared, how am I going to, what I can find from my quadratic is alpha plus beta and alpha beta. So how am I going to be able to find alpha minus beta all squared? Okay, so what we should note is that if I have alpha minus beta all squared, okay, it is this, let's expand this, it's the same as alpha squared. This one, alpha squared will give me alpha squared. Then I have minus beta times alpha times 2, that will be minus 2 alpha beta. And I have minus beta squared will give me what? Plus beta squared. Alright, so this is what I'm going to have. So my alpha minus beta all squared is going to give me what? Alpha squared plus beta squared. Let me bring that at one side. Minus 2 alpha beta. Alright, but alpha squared plus beta squared is what? Is alpha plus beta all squared minus 2 alpha beta. So I'm going to substitute. So my alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. Then I also have minus 2 alpha beta here. Alright, then what am I going to get? I'm going to have alpha plus beta all squared minus 2 give minus 4 alpha beta. Alright, so if I'm giving alpha minus beta all squared, then this will be the expansion. Alpha plus beta all squared minus 4 alpha beta. Then I can now get my sum here and then my product. Then I do substitution and I solve for the value of alpha minus beta all squared. So that will also be alpha plus beta all squared minus 4 alpha beta. Minus 4 alpha beta. So this is what we have for alpha minus beta all squared. I believe that is alright. Then with that, I believe I can write this. I have alpha minus beta. Okay, so there is a square here. So what will I do is the square root this side. I have alpha plus beta all squared minus 4 alpha beta. So if I am asked to find alpha minus beta, then I'll get rid of the square root by square rooting what? The other side of the expression. So that I have alpha minus beta to the square root of whatever I have here, alpha plus beta all squared minus 4 alpha beta. Okay, so we can also be asked to find alpha squared minus beta squared. Okay, so what is alpha squared minus beta squared? This is difference of two squares, alright? And I know when we started the quadratic, I taught difference of two squares. Okay, so if this is difference of two squares, then we can have what? Alpha plus beta and then alpha minus beta. Alright, so alpha plus beta, alpha minus beta. So alpha plus beta, you can get it from the quadratic because that is the sum of the roots. But alpha minus beta cannot be gotten from the quadratic, or we cannot get it. So what is alpha minus beta? That is square root of alpha plus beta all squared minus 4 alpha beta. So this is the same as alpha plus beta. Let me bring it down here. Alpha plus beta. And then square root of alpha plus beta all squared minus 4 alpha beta. We have alpha plus beta and then alpha minus beta, which is difference of two squares. So that when we expand it, you get this. So that will be alpha plus beta multiplying alpha plus beta all squared minus 4 alpha beta. So this is what we have. I believe that is okay. Okay, so let's see. You can also be asked to find maybe 1 over alpha plus 1 over beta. Okay, 1 over alpha plus 1 over beta. So how do I find 1 over alpha plus 1 over beta? So what we have to do is to find the LCM. So alpha, my denominator is alpha and then beta. So I have alpha beta. Alright. Okay, so I have alpha beta. Alpha goes into alpha. 1 remaining beta times 1. So I have beta plus beta goes into beta 1 remaining alpha times 1. So I have alpha. So I have here, can write it as alpha plus beta divided by alpha beta. So that here I have the sum. The sum is what? Alpha plus beta. And I have the product alpha beta. Alright. So all that we are doing is to make sure that you get the sum, either the sum and then the product. That is alpha beta and then alpha plus beta, or any of them, either both or any of them, so that we can solve. Okay. So let's look at number 6. Let's see, we have alpha 1 over alpha minus 1 over beta. Okay, so you can also be asked of this. So what we need to get is our alpha plus beta, or our alpha beta, or both. So let's find the LCM. So we have alpha beta here. Alpha will go here 1, and the remaining beta times 1. So beta minus beta will go here 1, remaining alpha times 1. That is alpha. Okay, so we have here as beta minus alpha, and then alpha beta. But you can see that we don't have beta minus alpha here. What we have here is alpha minus beta. So what we have to do is to make this one alpha minus beta. So we bring minus out so that it can be written as this. Alright. So minus into bracket alpha minus beta is the same as beta minus alpha. Minus times alpha will give minus alpha. Minus minus will give me positive beta. Okay, but at the end of the day, what is alpha minus beta? That is square root of alpha plus beta all squared minus 4 alpha beta all divided by alpha beta. So that now we can have our alpha plus beta all squared minus 4 alpha beta, and we can have our alpha beta. With this, we can solve this. Alright, so 1 over alpha minus 1 over beta can give us this. So number 7, 1 over alpha squared plus 1 over beta squared. Okay, so what do we have here? Alpha squared, beta squared. Alright, we have alpha squared and then beta squared. So alpha squared will go here, 1 remaining beta squared times 1. So we have beta squared plus beta squared will go here, 1 remaining alpha squared. So we have alpha squared. Alright, so this can be written as what? Alpha square plus beta square, and then divided by alpha beta all squared. Alright, so beta square plus alpha square is the same as alpha square plus beta square, and then to get alpha beta we bring the square out, okay, to be alpha beta all square, which is the same as alpha square beta square. And finally we can, what is alpha square plus beta square? That is what? Alpha plus beta all squared minus 2 alpha beta divided by alpha beta all squared. Alright, so this is what we have for 1 over alpha squared plus 1 over what? Beta squared. Okay, then let's look at 1 over alpha squared minus 1 over beta squared. Okay, so we have alpha square, beta square. Alpha square will go here, remaining beta square, minus alpha beta square will go here, remaining alpha square. So what do we have? Okay, so what we have here is alpha square minus beta square. So let's write this as alpha square minus beta square. That will be minus alpha square minus beta square all divided by alpha square alpha beta all square. So minus alpha square minus beta square, minus 1 give minus alpha square, and then minus, when you remove the bracket, then you get back the minus alpha square and then the beta square. Alright, so what is this one going to give us? Okay, so let me continue from down here. Then this one give us what? What is alpha square minus beta square? So we have minus alpha plus beta, and then alpha minus beta. Because we have alpha square minus beta square as alpha plus beta and alpha minus beta, all divided by alpha beta all square. Alright, then we can finally write this as what? As minus alpha plus beta, and then what is alpha minus beta? That is square root of alpha plus beta all squared minus 4 alpha beta all divided by alpha beta all squared, all divided by alpha beta all squared. So 1 over alpha square minus 1 over beta square is going to give us this, minus alpha plus beta, alpha minus beta. That is minus alpha plus, and alpha minus beta is for square root of alpha plus beta all squared minus 4 alpha beta all over the alpha beta all squared. So that is what we have for 1 over alpha square and then 1 over beta square. Alright, so number 9, let's look at alpha cube plus beta cube. Okay, and alpha cube plus beta cube can be obtained from alpha plus beta all cubed, as we did for alpha plus beta, alpha square plus beta square. So this is binomial expansion. The exponent is 3. So we can go by the Pascal triangle: 1, 1, 1, 1, 2, 1, and then 1, 3, 3, 1. So the cube is 1, 3, 3, 1. That's the coefficient. So our first one give us alpha cube, and then plus 3 alpha beta, 3 alpha square beta plus 3 alpha beta square plus beta cube. Okay, so binomial expansion has been taught in one of our lessons, so you can look at that and then know how to do the expansion of this. Okay, so let me make alpha cube beta cube the subject. So I'll send this one here so that I can have alpha plus beta all cube minus 3 alpha square beta minus 3 alpha beta square equal to alpha cube plus beta cube. So alpha cube, and then bring this one here. So I have alpha plus beta all cube. Let's try if we can factor it out. So minus 3 alpha is here, and then beta is here. Then we have what? Alpha remaining minus minus plus, then here to beta remaining. So we can have alpha plus beta all cube minus 3 alpha beta into bracket alpha plus beta. So that will be for alpha cube plus what? Beta cube. It will give us alpha plus beta all cube minus 3 alpha beta, then alpha plus beta. So this is what we can get for alpha cube plus beta cube. That is alpha plus all cube minus 3 alpha beta, alpha plus beta. Alright, so let's do alpha cube minus beta cube. So alpha cube minus beta cube. Okay, so what we should note is that this we are going to, if you have an expansion of, let's say, a cube minus b cube, we know that a cube minus b cube is the same as a minus b c, and then a square plus b square plus ab. This is if you expand this, if you have this, okay, a cube, difference of a cube, a cube minus b cube, this is how it is going to what? It is going to be. Let me try and expand this. You realize that I'll get a cube and b cube. See, okay, so let's see whatever we get here. A times a will give me a cubed, a times ab will give me ab square, a times this will give me a square b, minus b times a will give minus a square b, minus b times will give minus b cubed, then minus b times will give minus a b squared. So AB squared will cancel minus AB squared. And then A squared B will cancel minus A squared. So what do we have? A cubed minus B cubed. So you realize that the expansion of this has given me this. So we are going to use the same thing and write alpha cube minus beta cube, which will be the same as what? Alpha minus beta. Then alpha square plus beta square plus alpha beta. Okay, so this is the same as this. All right, so let me clear this and then we now look at it and see what we are going to do. Okay, so what do we have here? We have alpha minus beta, which you can have here, and then here alpha square plus beta square, which is also here. So what we are going to do is to substitute what we have here. So this can be what? Square root of alpha plus beta all squared minus 4 alpha beta. That is for alpha minus beta. And then this can also be alpha squared will give me beta plus beta will give me alpha plus beta all squared minus 2 alpha beta plus alpha beta. You see? So that we have our square root of alpha plus beta all squared minus 4 alpha beta. Then we will have alpha plus beta all squared minus 2 alpha beta plus alpha beta will give minus alpha beta. Okay, minus 2 plus 1. So this is what we are going to have. Square root of alpha plus all squared minus 4 alpha beta multiplying alpha plus beta all squared minus alpha beta. So that is alpha cube minus beta cubed, right? So this is what we have, and I believe we have gone through a lot. And let us end here. I believe when we are given a question, you should be able to solve them. Okay, thank you for your time. I will see you once again as we solve question on relation between the root and the coefficient of quadratic equation. See you for more. Bye bye.